Let's start with a new project. First of all, we're going to create a 3D plane. So we create a new mesh instance and select a plane. Now we're going to rotate it and move it up. After that, we're going to add a world environment and change the ambient light so the plane gets illumination. Create a new shader material and create a new shader inside it. In this case, it will be of the spatial type, unshaded, and we create the fragment function. The UV coordinates are just proportional quantities which go from 0 to 1, so they are normalized. With them, we can access to the positions of the fragments. It's important to understand that the fragments are not pixels. Rather, they are pieces of the triangles of a mesh covered by the pixel. The shaders participate in the process called the rendering pipeline. Normalizing the coordinates is part of this process. Now we go to GODOT and first save our shader to have easy access to it. Since the shader is of the spatial type, we have to assign the color with the output variable albedo instead of color. As you can see, if I pass the UV variable to the output, a color interpolation is produced. This is because the UV map goes from 0 to 1. So I get an interpolation at the x-axis and another interpolation at the same time on the y-axis. This is the same as splitting x and y. If I pass just the vector x to the RG channels, we get an interpolation on the blue channel. Now, if I assign x to all the channels, we have a black and white interpolation. The same happens, but on the y-axis. Here, I'm going to use a plotting function from the book of shaders. I'm going to copy and paste. It has a slight modification to adapt to the spatial shader type. And now, I am going to declare some variables in order to make the manipulation easier. This code below comes from the book of shaders, and this is for generate the graph. I will copy and paste the code here. I assign the output to albedo, and now you can see the graph. Here is the output function. For example, I can use a quadratic function. Also, I can use a fraction to generate the square root, or I can use the function directly. The log function that I don't know why it didn't work. You got the sine function, which you have to multiply because the value only goes from 0 to 1. I can use a function from easing functions, but first I had to modify it. So I have modified it. Now I am just going to copy it. I just replace the ternary blocks with else if statements, and I also changed all the values to floats. Finally, I can use the function, and here we have the result. Now let's review two very important functions, step and small step. We already used the step in the black and white effect to emphasize the difference after having converted the image to grayscale. First of all, step is going to give us this output, which, as you can see, is a sudden change, while the smooth step functions allow you to have a smooth transition. As you can see, right in the middle, there is a gradient between the two values. This is something that we can define in the function. If you notice, it's exactly the same as the step function, as long as define the two limits to be exactly the same. Usually, we use a small value to get a smooth line.